So here's another question from the homework. This is from lesson 3, friction number 15. This question is tough. So it says a 10,000 Newton elevator. Oh, they gave me the mg, the weight of the elevator, not the mass, is supported by a cable that has a maximum tensile strength, tension, of 100,000 newtons. If an average passenger weighs 800 newtons, what is the maximum number of passengers the elevator can safely carry at an upwards acceleration of 1.5 meters per second squared? Ooh, that's a good question. If you think about this question the right way, it's not too bad, but the tricky part is setting it up right. In fact, often I will forget how to set it up right and I have to rederive it. Of course, this is a job for a free body diagram. What we're going to do is we're going to lump the elevator and the passengers together. The first thing I'm going to do is figure out how many kilograms this elevator can handle before it would snap. Then I'll convert the kilograms into newtons, times by 9.8. I'll subtract the elevator, and whatever newtons are left, that's the passengers. In other words, what are the forces acting on it? I'm going to have mg, this m is of everybody, elevator and people, and tension up. And that's for the first part, part A, on the way up. So my equation is going to look like this. Tension minus mg equals ma. And I would like to find m. How many m's do I have in this equation? 2. How many would I prefer? 1. Well, for starters, why don't I try getting the m's to the same side? I'll plus the mg over. I'll get tension equals mg plus ma, or ma plus mg. I don't care. How many m's do I have? 2. How many would I prefer? 1. You know, it'd be really cool. It would be really cool if there was a grade 9 mathematical operation that I could pull out of my back pocket and convert this from 2 mg's into 1 mg. There is. I can write this as T equals m bracket g plus a. And now, how would I get the m by itself? What's the bracket doing to the m? Multiplying. So, divide. I get m equals t over g plus a. It's going to be 100,000 over 9.8 plus 1.5. And if I crunch that, I get that many kilograms, 8,850. How many newtons is that? Well, if I take that 8,850 times 9.8, that tells me the weight of the elevator and the passengers. And I get 86,726. Now, if I minus the elevator itself, that leaves me with 76,726 newtons for passengers. 76,726 newtons, that's the passengers. What was the weight of one passenger? The average passenger has a weight of 800. So how many passengers is 76,726? I divide by 800. And I'll use my answer button. And lo and behold, I get 95.9 passengers. So this elevator can handle 95 passengers, barely, without snapping. 96 passengers would put it just over the top, and the cable would snap. For part B, when we're accelerating down, I think the only difference is your equation is going to be mg minus tension equals ma. But then you'll do the same thing. You'll get the m's to the same side, swappy dance as we call it, factor out an m. I think you'll find that m equals, sorry, sneeze for those of you on YouTube at home, m equals t over g minus a. And then, just like we did right here, multiply by 9.8 to turn it into newtons, subtract the elevator, divide by 800, and that'll tell you how many passengers you can handle going down. Mr. Dewick, is this how they figure out when you walk into an elevator and it says maximum occupancy? Sort of. I suspect they build a really healthy safety margin in because they have to assume that you might be carrying something heavy or moving furniture or something like that. But yeah, otherwise they would know the strength of their cable and they would build a massive safety margin in. So if you got an answer of 95 passengers, you'd probably cap it at 20 passengers just to be really, really safe. But yeah, hope that helps.